Hello friends, now we'll start the chapter permutation and combination. Your exam point of view, it's a very important chapter. So we'll start this chapter with the first concept, that is fundamental principle of counting. Now, what does this principle says? Suppose if one thing can be done in m ways, and when it has been done in any of the m ways, a second thing can be done in n ways, then the two things combined together can be done in m into n ways. A very simple example: suppose if you want to travel from place from one place to other, and it is involving one stop. Suppose the m city to n city. Okay, so there are four routes to going to n from n m. Okay, now from n he wants to go to p, and there are only two routes. So in combination, the total number of possibilities, total number of combination, this number of routes which we can take is 4 into 2, that is 8 ways. Now these some very simple concept, factorial. So I'm just revising this concept. If you want to find out the factorial of any number, for example n factorial, you have to just multiply 1 into 2 into 3 into 4 into 5 up to n. Okay, and also one formula, that n factorial is equal to n into n minus 1 factorial or n into n minus 1 into n minus 2 factorial. For example, if you want to calculate the factorial of 5, so you just simply multiply 1 into 2 into 3 into 4 into 5, or you can represent 5 factorial as 5 into 4 factorial. Okay, these are some important properties. This I have discussed earlier also. 0 factorial is 1, and also 1 factorial is also 1. Factorial of a negative number, negative integers, are not defined. Okay, now we'll start with permutation. A selection and arrangement or ordering of set of objects is called permutation. Here order of object is very important. That means first A then B, and or first B then A. These two are different, but in combination these two are same. So in permutation, order of object is very important, and in combination order is not important. So I have written this selection and arrangement. Suppose you want to arrange these three letters by taking two letters at a time. So it will be AB, also BA, BC, CB, AC, CA. Each of these are representing a different arrangement of two letters. If it would have been combination, then this is only three arrangement. Okay, because in combination order of the object are not important. Okay, now number of all permutation of n different things taken are different things at a time, where n is always greater than or equal to r. The formula is this: npr is equal to n factorial upon n minus r factorial, where r is less than or equal to n. R can never be greater than n, because if r is greater than, then n minus r will be negative, and for negative numbers factorials are not defined. Okay, so this is very important formula. We'll take one example. How many different 5-digit numbers can be formed from the digits 1 to 9 inclusive? Okay, so there are 9 digits and we have to form 5-digit number. So we can write 9p5 ways. We can prove this in other ways also. So we'll solve this. So it was written that you have to form a 5-digit number. Okay, that means 1, 2, 3, 4, 5. 5 places are there. Okay, and the total digits are 9 digits. Okay, so the first place can be formed in 9 ways, second 8, third 7, 6 and 5. So the total number of ways is equal to multiplication of all this. Now there we have used this formula 9p5, Now we'll see what is the answer with this formula. This is 9 factorial upon n minus r, that is 4 factorial. So 9, I can write 9 into 8 into 7 into 6 into 5 into 4 factorial. Why I'm writing like this? Because I want to cancel this. So you'll get the same answer. This answer and this answer same. Here you have to keep in mind that in permutation the repetition of digits are not allowed. Sometimes they ask the question that repetition is allowed. So if repetition is allowed to form a 5-digit number, then your answer will be 9 ways, 9 ways, 9 ways, 9 ways, 9 ways for each of 5 digit. So the total ways is equal to 9 raised to 5. We'll see some more example to understand this. Okay, let us take one example. Here it is written that you have to form a 3-digit number using digits 4, 7, 9 and 3. Now if we want to form a 3-digit number, so there can be two cases. They will specify these cases in the exam. First, repetition is allowed. If repetition is allowed, we can choose the first digit in 4 ways because there are 4 digits, another also in 4 ways, and last one is also in 4 ways. So the total ways will be 4 cube, that is 64. In the second case, suppose it is written that repetition is not allowed. So in this case, if the first digit can be chosen in 4 ways, the next will be in 3 ways because we can't repeat the digits. Okay, suppose you have taken the first digit 7, then you cannot take this 7 at the second place, so you have to choose from these 3, so and the last one from the remaining 2. So your answer will be 4 into 3 into 2, that is 24 ways. Now I think it is getting clear. Now one more example. 3-digit number using 0, 1, 5, 9. First case, repetition is allowed. Means this can be formed in 4 ways. 4 ways, 4 ways? No. You have to remember that a number cannot start with 0. That's why the first digit can be written in 3 ways only. That is 1 or 5 or 9. Remaining you can write in 4 ways and 4 ways. So answer will be 48 ways. Suppose repetition is not allowed. The first number can be chosen in 3 ways, okay, because 0 is not allowed. Now the next number, since we have chosen, suppose we have chosen 5, so for the second we can choose 0, we can choose 1, we can choose 9. There is no repetition, so second one also in 3 ways and the last one in 2 ways because we have used 2 numbers. Okay, so the answer will be 18 ways. Now I think you are much clear about this concept, how to find this. Okay, now you can see here the permutation of n distinct object they taken r at a time. The repetition is allowed, then n raised to r, which we got in our problem, that 9 raised to 5. Okay, now this is very important formula. Okay, permutation of n object of where a few are identical is given by n factorial upon p factorial, q factorial, r factorial. Here out of n, p objects are one of one coin, but that means p is getting repeated, q is getting repeated, p number of times one object is getting repeated, q number of times another object is getting repeated, and so on. Here to understand this, we'll see a very good example. How many different permutation can be made out of the letter of the word assassination taken all together? In assassination there are 13 words, okay, 13 letters, sorry. So if we'll count the similar alphabets, the S is 4 times, A is 3 times, I 2 times, and N 2 times. So the number of permutation is 13 factorial, that is n factorial, upon, since S is repeated 4 times, we will have to write 4 factorial. Then this should be 3 factorial. Okay, it was wrong. This should be 3 factorial because A is repeating, getting repeated 3 times, I 2 times, and N 2 times. So therefore answer will be 13 factorial upon 4 factorial into 3 factorial into 2 factorial into 2 factorial. You don't have to get the final answer if the calculation is too tricky. Just leave the answer. Now we'll see some other example. This is very important example. In how many ways can 4 prizes to be given away to 3 girls when each girl is eligible for all the prizes? So you have to pick first prize. So you can give that first prize to any of 3 girls. That means first prize can be distributed in 3 ways. Okay, now you have to pick the second prize. Now since every girl, each girl is eligible for all the prizes, then the second prize also you can give to any of the 3 girls. That means second prize is also can be distributed in 3 ways. Similarly for third prize, and similarly for fourth prize. That means all the prizes you can distribute in 3 ways. That means 3 into 3 into 3 into 3, 3 raised to 4 ways. There are certain rules for permutation. Npn is equal to npn minus 1 is equal to n factorial. These rules will help you in the calculations. Np1 is equal to n, and np0 is equal to 1. You can definitely derive these things, but for faster calculation you should remember. Okay, now we'll see one more example. How many different permutation can be formed with the letters of the word computer? How many begin with C? If you carefully see, the in computer no alphabet is repeated, so number of letters is 8, therefore number of arrangement is 8 factorial. Now if you want to fix the place of one alphabet, then you have to arrange the remaining one. So here in our question it is said that it should always begin with C. So there then you'll have to arrange only remaining 7 letters. So the remaining 7 letters can be arranged in 7 factorial ways. Now the next example, a family of 3 brothers and 2 sisters is to be arranged in a row of photograph. Please keep in mind, if the question comes that you have to arrange on a stool, arrange on a bench, arrange for a photograph, and the linear arrangement, it is always talking about the permutation. Okay, so there is one condition in this, and how many ways they can be seated if all the brothers are to sit together. That means the brother should be together. Okay, so here I have assumed that m1 m2 m3 for brothers and w1 w2 for sisters. Okay, since the brothers are to be seated together for photograph, consider them as one entity m, and the remaining w1 w2. So these 3 things, that is one bunch of brothers and 2 sisters, are considered as 3 objects. So these 3 objects can be arranged in 3 factorial ways, and the 3 brothers m1 m2 m3 can be arranged among themselves in 3 factorial ways. That means the total number of ways is 3 factorial into 3 factorial. Suppose there would have been no condition as such, then the simple answer would have been 5 factorial, because the 3 brothers plus 2 sisters is equal to 5. Now this is one very good example. How many ways can the letter of engineering be arranged? And in that also there are 2 conditions. The in how many ways the E will come together and the E will not come together. So first we'll write the general arrangement for engineering. There are 11 alphabets in which E is repeated thrice, N is repeated twice, G is repeated twice, and I is repeated twice. So I have to find by this formula which I have done earlier, 11 factorial upon 3 factorial, 3 factorial, 2 factorial, 2 factorial, in which if I have to find the number of arrangement in which E is coming together, so we have to treat the 3 E's as one entity. So 11 minus 3, that is 8 alphabets remaining, and if we'll assume the 3 E's as one object, then 8 plus 1 9, you have to assume as 9 alphabets. Okay, now if you'll find the arrangement, it will be 9 factorial because now it is 9 upon 3 factorial into 2 factorial and 2 factorial. Remember, here we have taken this 3 factorial for E, but now if we are assuming that A should be coming together only, then we have to eliminate this in this one. Okay, now if I want to find the number of arrangement when where E is not coming together, it is very easy. This is total number of arrangement. In these arrangement the E is coming together, just subtract, so you will get the arrangements where E will not come together. Now next problem, find the number of words formed with the letter of the word Nasik which begins with N and end with K. That means there are 5 places. First one is fixed, last one is fixed. Okay, so one way, and now the remaining 3 can be chosen in 3 into 2 into 1 way. Okay, that is 6 way. You can also write 3p 3 ways. The total number of way will be 6 into 1 into 1, that is 6 ways. Now the next concept is circular permutation. There is very thin line of difference between circular permutation and linear permutation. Linear we have already studied. Okay, now we'll see what is the difference between linear and circular. Suppose you want to set the 4-person, you want to set the 4-person on a circular table A B C D. So the arrangement is like this, and if you'll move them in a clockwise or anti-clockwise direction, the movement is like this: A B C D and A B C D, A B C D. But in linear arrangement, if you'll move A B C D, A B C D, A B C D, A B C D, that means if you'll see here, the order is same always. Okay, A B C D, but in linear the order is different. That means uh, the the clockwise thing and the circular thing is coming together. Okay, that means in the circular permutation there is repetition of the arrangement, so we'll have to subtract 1. So always if there is n number of objects, then linear arrangement will be always n factorial. Okay, but for the circular there will be n minus 1 factorial because there is lots of repetition. Here you have to remember that clockwise and anti-clockwise arrangement are different. Okay, A B C D clockwise and A B C D anti-clockwise will be different. In how many ways can 4 boys sit around the table? Since n is 4, you have to just find 4 minus 1 factorial, that is 3 factorial. Now this is another concept, that if you want to arrange beads or flowers around a garland, okay, or a necklace. So here only difference between above concept and here this concept is, here clockwise and anti-clockwise permutation is same, because you can turn the garland. Okay, in exactly from, you can see that from the back side also. So here the total number of permutation will be half of n minus 1 factorial. For example, in how many ways can a 10 differently colored beads be strung on a necklace? Because it's a necklace, that means clockwise and anti-clockwise permutation arrangements are same. Therefore, you have to find the 10 minus 1 factorial, that is 9 factorial, divided by 2. Now the next concept is combination. A selection of set of object is called combination. Here order of object is not important. I have discussed this earlier also. Here order is not important. So the formula is NCR is equal to n factorial upon r factorial into n minus r factorial. Here are some of the rules. NCR is equal to NCn minus r. NC0 is equal to NCn is equal to 1. NCR is equal to NPR upon r factorial, because you can see this r factorial. NC1 is equal to n. Now we'll see one example where they have written the two values, two combination values, and find out the value of r. Here they have written that NCR minus 1 is 36, NCR is equal to 84, and NCR plus 1 is equal to 126. Then find the value of r. So NCR upon NCR minus 1 is equal to 84 by 36. If you'll simplify this by putting that formula, you'll get this. Okay. If you want to understand how we are getting this, I'll explain you. It is given that NCR upon NCR minus 1. So I can write this as n factorial upon r factorial n minus r factorial into n factorial, because I have taken this division into multiplication. I am transferring r minus 1 factorial n minus r minus the minus 1 will become plus factorial. So these two will be get cancelled. So r minus 1 factorial n minus r plus 1. This for this I'll use the formula that n factorial is equal to n into n minus 1. So n into n minus 1, that is n minus r factorial, because minus 1 and plus 1 will get cancelled. For r factorial also I'll use r into r minus 1 factorial. This will get cancelled, this will get cancelled, so you'll get n minus r plus 1 upon r. So I think now it is clear how to derive these things. So after solving the first two things, we'll get this equation is equal to 7 by 3. Okay, so after solving this, I'm getting one equation that is 10r minus 3n is equal to 3. Now we'll solve another one, that is this and this. So we'll get another equation which is 10r minus 4n is equal to minus 6. After solving this, we can find out the value of r and n. Now we'll see what is the exact difference between permutation and combination. In permutation, as I told you that we'll only see the selection and arrangement both. Okay, but in selection we'll only see the selection. Here order is not important. Suppose if you want to check that there are four objects A, B, C, D, from which three objects are have to be taken. So the first combination, first selection is ABC. Now, in this ABC, we can have multiple types of permutation: ABC, ACB, BAC, BCA, CAB, CBA. That means in a single combination, we are getting 6 permutation, because in permutation order is important. So, similarly for all others, you will get number of combination is equal to 4 and number of permutation is equal to 24. So, this is the difference. Now we can see the problem of permutation is like arrangement, standing in a line, sitting in a row, problem on digits, problem on letters from a word. Problem of combination is selection, choose, distributed groups is formed, committee, geometrical problems. Okay, so now we'll solve some problems, some examples. Example: out of 10 men, in how many ways can 6 be chosen? It's very simple, 10c6. Out of 10 men, in how many ways can all the 10 is chosen? That is 10c10. That is one way. From 4 gentlemen and 6 ladies, a committee of 5 is to be selected. Find the number of ways in which committee can be formed so that gentlemen are in the majority. Here the condition is gentlemen should be in the majority. The committee will consist of 4 gentlemen, 1 lady, or 3 gentlemen or 2 ladies and 2 ladies, because we cannot keep 2 gentlemen and 3 ladies. Okay, because they have given the thing that gentlemen should be in the majority. So this is one possibility. This is another possibility. These two are connected with or, then we'll have to add that. So total number of gentlemen are 4. So 4 gentlemen can be selected from 4 gentlemen in 4c 4 ways, and 1 lady can be selected from 6 ladies in 6c1. Okay, the next one is 3 gentlemen for 4 from 4, that is 4c3, and 2 ladies from 6, that is 6c2. So you'll have to multiply and add. The final answer you'll get is 66. Now we'll solve gate problems based on this chapter. Uh, First problem which is asked in 2010, given digits 2 2 3 3 3 4 4 4 4. That means 2 times 2, 3 times 3, 4 times 4. How many distinct 4-digit number greater than 3000 can be formed? Okay, that means they want to form numbers that should be greater than 3000. Okay, so if I want to solve this, I'll solve by starting by this, that if I want to form the number greater than 3000, then there will be two cases. Okay, that the first digit is either 3 or 4, because we cannot start with 2. So we'll take these two cases separately. Now the first case, the 4-digit number is to be formed, and the numbers available number is 2 2 3 3 3 and 4 times 4. Okay, now since in the first case we have considered that we'll start with 3. Okay, so this is fixed. Now these 3 can be filled, the first first. Now just see that you can take one of the 2 here. Okay, then you can take one of the 3 here, and you can take one of the 4 here. Here we cannot count the total number of digits available, because there is repetition in the given digits. So we have to take unique digits only, because 2 and 2 both are same. So 3244 and 3244 both are same. So we cannot use 2 in the calculation. It will increase our number of arrangement. Okay, so the all the 3 numbers can be arranged in 3 into 3 into 3, 3 into 3 into 3 ways. Now this I have written 3 into 3 into 3 into 3 ways, that is total 27. But okay, since we have only two number of 2's, so we cannot have 2 2 2 in these 3 places. Okay, so I'll have to subtract that. And also, since I have used 1 3 to start the number, so for these 3 places we cannot use 3 3 3 also. Then again I have to subtract this one also. So the for first case the answer is 25. In the second case, where I'm starting with 4, there are 3 possibilities, 3 places. Again 3 into 3 into 3 is equal to 27. But here I can use these 3 3 3 3 3, these 4, but I cannot use 2 2 2 over here. So I'll have to subtract, that is 26. So total ways is equal to 25 plus 26, that is 51. I have written all these here, so you can read this also. Okay, just to explain, I solved this. Okay, so 25 and the next case 26. So answer is 25 plus 26, that is 51. Now we'll see next problem. This is a very simple example we have done in our one of the example. How many ways 3 scholarship can be awarded to 4 applicants when each applicant can receive any number of scholarship? First scholarship 4 ways, second scholarship 4 ways, third scholarship also 4 ways. That means 4 into 4 into 4, that is 4 raised to 3. The 64 ways is the right answer. Now the next problem is that 10 teams participated in a tournament. Every team play each of the other team twice. The total number of matches to be played. Actually this is very good example, very good question. But here written is every team plays each of the other team twice. Suppose this condition would not have been there. It has written that every team will play only once with other team. Then it is NC2, where n is the number of teams. So here the number of team is 10. So the total matches will be 10C2. If you'll solve this, you'll get the 45. But here the condition is written every team plays each of the other team twice. So you have to just multiply by 2. So 45 into 2, that is 90. So 90 will be your answer. The total number of matches will be 90. Now this is also one very good question asked in your GATE paper 2012. Consider the set of integers 1 to 5000, the number of integers that is divisible by neither 3 nor 4. So you have to find which of these is neither divisible by 3 and nor 4, and give the answer. So to solve this, we'll find the digit which are divisible by 3 and 4 both. Okay. So to start with, the number 3 is divisible by 3, number 6 is divisible by 3, and up to 4, 9 and 8. So the total number of digits which are divisible by 3 is 4, 9 and 8 by divided by 3, that is 1666. The number of integers divisible by 4 is 4, 8, 12, 16, 20 up to 5000, because 5000 is also divisible by 4. So the total number is to 5000 divided by 4, that is 1 to 50 members. But here can you see 12 and this 12 is common. Similarly 24 and 24 is common. So we will have to find the number of digits which are divisible by LCM of 3 and 4. So LCM of 3 and 4 is 12. So the integers that are divisible by 3 and 4 both, that is 12, 24, 36 up to 4992. So the total number is 4992 upon 12, that is 416. Add these two, subtract this common from them. So you'll get the number of integers that are divisible by either 3 or 4 is 1666 plus 1250 minus 416 is equal to 2500. Now these 2500 numbers are divisible by either 3 or 4, and you have to find the number of integers that are divisible by neither 3 nor 4. So you have to subtract this 2500 from this 5000 and you'll get the answer as 2500. So it is which option? It is option C. That means your answer is option C. Thank you.